Today we're going to talk about section 4.5 in your Geometry BJU Press textbook. We're going to be looking at the polygons. In specific polygons, we're going to be looking at triangles and quadrilaterals. So we're going to be able to classify triangles and quadrilaterals. Triangles can be classified by the type of angles and how many congruent sides they have. Quadrilaterals can be classified by their types of angles, their lengths of their sides, and their pairs of parallel opposite sides. So let's start looking at our three different types of triangles when we're classifying them according to their angles. Their first type is an acute triangle, and that has three acute angles. So acute means less than 90. A right triangle is a triangle with a right angle, which is 90 degrees. And an obtuse triangle is a triangle with an obtuse angle, which is more than 90 degrees. So here we have an example of an acute angle, or an acute triangle. Here's a right triangle, and then here's an obtuse triangle. Then let's talk about how we can classify triangles based on how many congruent sides they have. If they have no congruent sides, remember congruent means it has the same measure. So if the triangle has no sides that have the same measure, they have no congruent sides, that means it's a scalene triangle. An isosceles triangle has two congruent sides. And an equilateral triangle is a triangle with three congruent sides. It's important to note that equilateral triangle has three congruent sides. We also have something called equiangular, which is when all three angles are the same. So here's our scalene triangle. And as you can see, none of the sides are congruent. Here's an isosceles triangle. It has two sides congruent. So notice the little tick marks on the two sides that are congruent. And then at the bottom here we have our equilateral triangle, and all three sides are marked as congruent. Okay, so in an isosceles triangle, the two congruent sides, we call those the legs of the isosceles triangle, and the side that's not congruent is called the base. And the angles that are formed at the base are called the base angles. And then the angle that's formed by the two legs is called the vertex. So here's an isosceles triangle. So these would be the legs, the two that are congruent to each other, which means that AB would be your base, which means that angle A and angle B are your base angles, where angle C is your vertex. Now let's move on to quadrilaterals. In order to classify quadrilaterals, we have to go over what does opposite and consecutive mean. So consecutive is the opposite of opposite. So these would be opposite sides, and so these would be consecutive sides. So consecutive sides actually meet at an angle. These would be opposite angles, and these would be consecutive angles. So consecutive angles have a segment that go in between them. So our first type of quadrilateral is called a trapezoid. And that's going to be a quadrilateral with one pair of parallel opposite sides. If you have two pairs of parallel opposite sides, you have what's called a parallelogram. So a trapezoid is one pair, a parallelogram is two pairs. Then your parallelogram becomes a rectangle if all your angles are right angles or 90 degrees. And then your rectangle is going to become a rhombus, your parallelogram will become a rhombus if all your sides are congruent. So a rhombus doesn't necessarily have to be 90 degrees. It can have any angle at once. It just has all four congruent sides, and those have to be parallel sides. Now, if you have a rhombus with four congruent angles and four congruent sides, or a rectangle with four congruent sides, you're going to have a square. Okay, so we're looking at this. This has one pair of parallel sides, which makes it a trapezoid. So notice that there's only one pair of parallel, and then the other set is not parallel. So it's not a parallelogram, it is just a trapezoid. Now we have this. This is a parallelogram because both sides on the parallelogram were parallel. Now we have what looks like a parallelogram because we have two pairs of parallel lines, but notice the angles. They're all right angles, which makes this a rectangle. Now this, we have parallel sides, so it's a parallelogram. However, all the sides are congruent, which makes it a rhombus. Now here we have a rectangle, and all four sides are congruent, and all four angles are 90 degrees. We also have a rhombus, where all the angles are 90 degrees. So that means that we have a square. So let's try some questions. A trapezoid is a parallelogram. That would be false, because remember, a trapezoid only has one side. It only has one pair of parallel sides, and a parallelogram has to have two pairs of parallel sides. Next question. A parallelogram is a trapezoid. Now this would be true because a parallelogram has two and a trapezoid only needs one. So it exceeds the definition of trapezoid, so which means that it is a trapezoid. All squares are trapezoids. That is true because all squares have at least one pair of parallel sides. No rectangle is a rhombus. That would be false because remember, a rhombus that has four congruent angles becomes a square, and a square is a rectangle. An equilateral quadrilateral, so equilateral means all the same sides, is a rhombus. That is true. All rectangles are parallelograms. That is also true. A rhombus is a rectangle. That is false because a rhombus just needs to have equal sides, right, congruent sides, but the angles on a rhombus do not have to be equal, which means that it does not have to be a rectangle where all the angles have to be 90 degrees. Now, if you were to look on page 147 of your textbook, you would notice a really cool Venn diagram where it has a universal set of quadrilaterals and it shows the relationships between the different types of quadrilaterals. So it'll show that every trapezoid is a parallelogram or is a quadrilateral, and every parallelogram is a trapezoid, and every rectangle is a parallelogram, and every rhombus can be a rectangle, but sometimes it's not. Sometimes a rhombus is just a parallelogram. And then it shows that every square is a rhombus and a rectangle. So it's a very neat little Venn diagram. You should check it out and then go try some problems.